Welcome to the Lesson 7 quiz, and we're going to go ahead and get started. Number 1. What are the factors to be considered in determining the allowable load for wood-to-wood mechanical fasteners? Sorry, I was thinking. I know I read it out loud, but I really didn't understand what it said. Okay, so what it's saying is, which of these matter? And number 1 is lumber species, and that I know that matters. And you can go back and look at the beginning of the section and you'll see that. Fastener spacing and edge and end distances, I know that matters. Angle of load to grain, and that also matters. So I'm going to go with D. 1 is D, all the above. I don't know how long I'll keep this up, but 1 is D. Let's go on to number 2. 2 3/4 inch steel plates are connected to a 1 inch plate. So you have what? 2 3/4 inch plate. I'm just kind of drawing this on the fly. Hopefully I draw it correctly because I haven't read this ahead of time. Okay, so this is a 3/4 inch plate. And you have another 3/4 inch plate. It's connected to a 1 inch plate using, so this is a 1 inch plate. Let's change colors. Let's go with something a little bit more dynamic. Pink is always good for bolts. They pop. Alright. Using 3/4 inch bolts. Let's just put them right here. So it's bolts. It doesn't say how many. Does not say. I have a bad habit of saying doesn't. Apparently I'm 3-4 years old. Alright. 3/4 inch diameter bolts. ASTM A325 slip critical SC. That's what that stands for. As shown below. Oh, it actually shows it below. That was stupid of me. Oh, and it says 4 of them. I'm going to trust what it says, and it actually drew it exactly like I did. Alright, so you have, well, let's go ahead and just, let's change colors again. I'll go with purple. I like how the purple stands out. I'm always afraid that the purple will not stand out since it's dark, but it stands out rather well. I'll have to use it more often. My father went to K-State, so there you go. I grew up as a K-Stater, a Wildcat. Alright, no, this is P over 2. Because it's a double shear. So I guess I just kind of pointed out the first thing. We have a double shear situation because right there and right there are your 2 shear planes. And we're saying slip critical connection as shown below. What are the plates? ASTM 36 steel, the plates. What is allowable P? Alright, so we're looking for allowable P. So we need to figure out what is allowable slip crit. Allowable SC, 1, and 2 is bearing. And it's going to be the bearing of this 1 inch plate, because if you think about it, bearing on 1 inch plate is going to be ratio larger than bearing on 3/4 inch, 2 3/4 inch plates with the same load. So that'll be equivalent of 1.5 inches compared to 1. So this will control, and I hope you can see that already. So let's go ahead and go to the steelbook. So if you remember, we used a table for these in the past. So let's go to the connection section and just start going to the right and see which table works out. And it looks like allowable page 4-5, bolts, threaded parts, and rivets, shear, and then allowable load in kips. And we have A325 bolts. SC, Class A is what we want, slip critical. And we have standard holes, I believe. And then we want loading. It says S or D, which is single or double shear. And we go over to 3/4 inch nominal diameter. And you see that 15.0. That's what we're getting. 15.0 kips. And remember, we have 4 bolts. So that's 60 kips. And then bearing, let's take a look at bearing. And really, like, there's a lot of things in structural engineering. There's two ways to go about getting the bearing. One, you could just flip a page and you could go to allowable bearing and bolts and threaded parts. We say that we have FU of 58 bolt diameter, and that's for 36 KSI steel, and that's something that you can look up. What is the tensile strength, the ultimate tensile strength? You see we have 3/4 inch. This is on page 4-6 of your steel manual. We have 3/4 inch bolt diameter, and then you go down and we have 1 inch material thickness, and you see 52.2 and 52.2. Oh, that's 52.2 kips times 4 bolts equals 208.8 kips. That's one way you could do it. Also, the way I prefer to do it is, when we did this in some of the previous videos, is to say, okay, you know the allowable bearing. You have, this is one of my more intuitive ways to go about it. You have what? Okay, you've got a 1 inch thick, and tell you what, I'm going to do this real quick. I think this is going to be good, or worth it, because sometimes we glaze over these things. 2, 3, 4. We have 4 bolts, correct? And we know that these are what? 3/4 inch? Yeah. These are each 3/4 inch, correct? And this is showing the outside diameter there. 3/4 inch diameter. So when this pulls that way, it's going to hit the metal 3/4 inch, correct? And then we know it's also an inch deep. So the area that's going to hit on per bolt is 3/4 inch times 1 inch equals 0.75 inches squared. I hope that makes sense. And then we're going to hit that times 4 bolts. So 0.75, times 4 equals 3. And that's 3 inches squared total between all those bolts. Okay, so you have 3 inches squared, and then you want to hit that times our allowable, which is 58, times 1.2 for bearing. And you can go in the specs and you'll see that. I'm not going to go look it up right now, what it is or where it is exactly. But we've done it before in past videos, and you can see, and once again, you get 2.8. So this number isn't magic from the table. This is where it comes from. And since this is much larger, the capacity of this plate to handle that. Now, if you could even figure out the bearing for these 3/4 inch plates as well, but there's no point, because it's going to be more than this, because we know that. But as you can see, I shouldn't have underlined it. That might be confusing, given that I typically underline the answer. We'll put a box around it, and we'll put controls. So this has a higher capacity, or higher allowable, so therefore the lower will control. Makes sense? So if you're allowing 60 and you do 80, it will bust it, as compared to 80, won't even touch it. You still have plenty of capacity. All right, I think I beat that like a dead horse. Let's see if we actually had, we had 60 kips, and that's A. Number 2 is A. Let's go back to white. Number 2 is A. And let's erase. I need to find a good way to erase all this stuff. Maybe a different program than the one I'm using. Anyways, there you go. Moving right along. Let's go to purple again. All right, number 3. Which of the following welding symbols corresponds to the weld shown? And that's a fillet weld. So you know right off the bat, a fillet weld looks like this. And this is just about knowing. A fillet weld like this, if it were in the field, it would have a little flag like that. It means it's a field weld. A fillet weld typically will look like this. And since it's on both sides, it will look like this. And I'm assuming it's not all around. All around is this right here. It means it's all around the you do a fillet weld all around, can look like, and get rid of that. It would look like that. It means fillet weld all around, and that's if you have, you know, something like this type of situation. It kind of depends which situation you're looking at, but that's what that means, all around. So the answer is D. 3 is answer D. All right, we have about 5 minutes left. I'll keep going. Number 4, a connection is subject to vibration. Which of the following fasteners are appropriate? Subject to vibration. So when it's subject to vibration, that means it's going to go back and forth a little bit. I guess you could think of it as like fatigue type of a condition. And I'm going to say slip critical is what you want, because it's going to not allow it to move. And therefore, ASTM A325 slip critical, sure, as long as it's good enough. So 1, and ASTM 490 slip critical. So 1 and 4. The answer for number 4 is A. All right, and that's because you don't want that bolt to be back and forth. Sooner or later, you're gonna get a little bit of fatigue in there. It's gonna crack, and that's not a good thing. All right, which of the following fasteners has the greatest strength for wood-to-wood joints? Which of the following? All right. And this one, let's look at our answers. Our possible answers is common bolt, high strength bolt, shear plates, split ring, lag screw. And I'm going to tell you right off the bat that I do not like this question. When you ask me, and I apologize, I don't mean to be hateful, but it says which of the following fasteners has the greatest strength for wood joints? And right away I look at greatest and I think, okay, that's going to be 1. You're going to pick one of them, and all the answers have 2 or more. So that confuses me right off the bat, and I don't like it. But let's just go ahead and look at the answers, and you can go back and read through the beginning and see if you agree with it or not. So let's go back here, and looks like the answer is C, 1, 3, and 4, which is common bolt, shear plate, split ring, which the lag screw is not as big, I guess. Yeah, the lag screw, if you look at the page 117, you can see the lag screw is under bolts, which high strength bolt doesn't like that, or common bolt. And I think the high strength bolt, I don't think I've ever seen it used specifically. It's more for steel connection, not a wood joint. So I think that's why that may be wrong. But I encourage you to go look through that and decide for yourself. I am not going to do that. So we're just going to say the answer. And I apologize for not being horribly complete, but that's all right. We'll all live. Okay, number 6. What is the most common fastener for steel joints? And I know this right off the top of my head. Once again, I encourage you to go back and read through if you don't believe me. But rivets are old. That's C. Common bolt is not true. Interference body bolt is also not true. It is going to be B. High strength bolts are by far the most common thing done today because they are low maintenance. They're easy to do. You know, it only takes one person to have a wrench, or you can even have a torque wrench. All right, and we have a minute left, so I'm going to go ahead and wait. Actually, I'm going to go ahead and do number 7. That looks pretty easy. I have a minute, so 45 seconds. Let's see when we do it. What type of welded joint is shown above? And that is a butt joint. And that's one of those things you just got to know. So I take a look at the types of joints, either in your steel book or in this study guide, and you can understand what it is. So the answer for number 7 is A, a butt joint. And then I remember that because they butt up against each other. All right, thanks. I will see you for the conclusion of the Lesson 7 quiz on the next video.